Okay, so the problems we're going to look at today, just similar to what we did yesterday when we left off.
Maybe not say no. Just figure this one.
Actually, let's do this. That's good. Okay, so what we need to do here today is we're looking at what happens if we machine off the corner of this, just like we started yesterday. So we're machining off the corner of a block like that. And I'm going to keep the shadow of this in here, of these lines. And remember, we mentioned yesterday, now yesterday I gave you dimensions, today I'm just going to give you angles. But if we run this over here at a right angle, the angle of rotation is this angle right here in the purple. So that's my angle of rotation. So I've got to find that angle. My angle of tilt is found by connecting this down here. Now this becomes my right angle. My angle of tilt is this angle up here. So that angle sits vertically. So we're going to draw this out using a 3-view drawing. This is our top, and this is the corner that we're cutting off. So from the front view, it looks like this. And from the right end view, it looks like this. And yesterday what I gave you was I gave you this dimension here, which of course is the same as this dimension here. I gave you this dimension here, which is the same on both pieces. And this dimension here that's the same on both pieces. Today, rather than giving you those dimensions, I'm going to give you this angle, which is going to be 29 degrees in this piece, and this angle, which is going to be 38 degrees for this piece. And from those two angles, we need to be able to find the angle of rotation and the angle of tilt. Now, just like we were doing with the drilling, when we were given the angles for drilling, we weren't given any dimensions. We were able to just pick our depth, our thickness of the part, and use that. The exact same type of thing happens here. The angles determine the rotation and the tilt, regardless of what the depth is. So we can pick a depth. So right here, we can pick whatever we want this depth here to be, and use that then to figure out everything else. So I'm going to call it 10 millimeters.
You can just pick any depth.
I can pick any depth.
99.
You can say 99, yeah. I'm picking 10 because 10's a nice round number. 10 or 100 or 1,000 usually work well. So now I'm going to find here this length L. To find that L, I'm going to use this triangle. Now again, this isn't the real length L, it's just L based on my chosen depth. But again, all the angles are going to be proportional. All we're looking for is angles here. So if this is 10 millimeters, and this is 29 degrees, we're looking for this side up here, L. How do I find L? Well, what trig function am I going to be using? Tangent, because I have the opposite side. 10 is the opposite side, and I'm looking for L, which is the adjacent side. Tangent to theta is opposite over adjacent. So then I plug in my numbers. I have the angle of 29 degrees. The opposite side is the 10 millimeters. The adjacent side is L, which is what I'm looking for. So to find that, I put that over 1, and I will cross multiply and divide. 1 times 10 is 10, divided by the tangent of 29. 18.040. Millimeters. Next, we're going to move over here, and I'm going to find this width here, which I'm going to call W. And I'm going to do that from this triangle. You can't put these angles in the top view, because if you're looking at here, this would be the 29 would be right there, and the 38 would be right over here. So you can only see them from the front and the side. Yeah, from the top, you wouldn't be able to see them at all. So this is 38 degrees. This is 10 millimeters still. We're looking for W up here. So this is again a tangent. Oops. Tangent of theta is opposite over adjacent. I'm going to fill in my angle of 38 degrees. Opposite side is 10. My adjacent side is W is what I'm looking for. So again, I'm looking for a missing side, so I put that over 1 to make it a proportion, and I'm going to cross multiply. 1 times 10 divided by the tangent of 38 this time. So 1 times 10 is 10 divided by the tangent of 38. 12.799. So this is 12.799 millimeters. Now that we have those dimensions, we can find our angle of rotation. Our angle of rotation is technically defined, once I draw this in at a right angle, is defined to be this angle here. But that angle will be the same as this angle here. So if I draw that triangle out,
Which one you done on again?
the top view. This one right here. That's the hard part of these, is you got triangles going in every direction. So we've got 18.040 here and 12.799 here. And again, like I said, we're cutting this across here at a right angle. This is the angle we want here. But it's going to be the same as this angle here. So the question comes up, why are those the same? Well, because this is in a right triangle. This is the right angle here. This angle and this angle have to be complements, don't they? Well, this is a right triangle here as well. This angle and that angle must also be complements. So if both of them are complements to this angle here, they have to be the same angle. So those angles will be the same. So I'm going to find this R here so that I'll know that one. This R will have the opposite and the adjacent side, so I'm dealing with tangent. I fill in what I know. I am looking for R. I have the opposite side of 18.040 and the adjacent side of 12.799. So it is an inverse tangent, 18.040 divided by 12.799. 54.65 degrees. So again, that is telling me this angle here is 54.65 degrees. which means this one is 54.65 degrees. That is my angle of rotation. So that's R. Now to find my angle of tilt, and this is where it gets tricky. My angle of tilt, if I go back up to my original drawing here, my angle of tilt is this angle right here. It can be really tough to visualize this triangle here. This angle right here. It's this triangle here that goes up the corner to this edge here, up the edge to this corner, and it cuts across. This line cutting across is this line here. So what the triangle we're looking at goes straight down below this line here. This here is the edge of the box. That goes straight down, and it angles from this point down to the bottom of that. So it kind of pulls out of there looking like this. This is my angle of tilt. This depth here is the 10 millimeter depth that I chose up here, right here. That's that depth. It's that edge. The top of this length is this length here, across here. So I have to find that length across there. So to find that length, I'm looking at just this piece of the triangle now. This is a right angle. This down here is still 18.040. And this is the 54.65 degrees. This side, I'm looking for this side in red. That side would be the adjacent side. And now because I'm looking at a different triangle, the 18.040 millimeters is the hypotenuse of this triangle. So I pulled this piece out of that bigger triangle. So adjacent and hypotenuse is cosine. So I'm going to plug in what I know. The angle is 54.65 degrees. The adjacent side is what I'm looking for. The opposite, or the hypotenuse, is the 18.040. So again, I'm going to put this over 1 so I can cross multiply and divide. So this will be cosine of 54.65 times 18.040. Make sure you close that parentheses. Times 18.040 and then divided by 1. So I get 10.437. Now again, that distance, that is this length across here, which is, on our main figure here, that's this length right across here in green, up here. So again, what I'm looking at is this triangle here. So I have it right here. I've got the 10 millimeters of height. I just found this to be 10.437 millimeters. I need this angle. Well, it's going to be a tangent. It's inverse tangent of, which side's the opposite side? 10 over the adjacent, 10.437. So my angle of tilt, second tangent, 10 divided by 10.437. 43.78 degrees. So my rotation, I found to be 54.65 degrees. My tilt, 43.78 degrees. Not a lot of fun, is it? Like I said, it's visualizing those triangles, keeping track of which right triangle am I working with now and where is it on the original piece. It's kind of tricky. So we're going to step through one of these step by step right now. Same type of problem. So again, we're going to cut off the corner. So I'm drawing the shadows here. So if I'm looking at it from the top, looks like this. Something like that. Looking at it from the front. Let's say this angle here is 21 degrees. Looking at it from the right end. That angle there, we're going to go at 32 degrees. Now the first thing we're going to find is the angle of rotation. But to find it, we must know, or we must have some numbers for this length and this width. Now we said we could pick whatever we wanted to for this depth, but for the sake of consistency here right now, I'm going to tell you we're going to use 10 millimeters for that. So what I want you guys to find right now in your notes, find the length and width here based on that 10 millimeter depth. So I'm going to give you a couple minutes to do that, and then we're going to talk about it. Let's see what we got here. So to find the length up here, I'm going to use this triangle here. So this is 10. This is 21 degrees. That's going to be a tangent. So it's going to be the tangent of 21 equals 10 over L. So put this over 1 and cross multiply and divide. 1 times 10 is 10, divided by the tangent of 21. Giving us 26.051 millimeters for that length. How many of you got that? Any questions on how we got it? Okay. So the width, remember the width is also this dimension here, it just flips up. We're looking at this triangle. This is still 10, this is 32, and this is my width. So that's going to be the tangent of 32 degrees is equal to 10 is my opposite, and the width is my adjacent. So I put this over 1 so that I can cross multiply and divide. 1 times 10 divided by the tangent of 32. So 1 times 10 is 10. Divided by the tangent of 32. 16.003. How many of you got the 16.003? Okay, so any questions so far? Okay, so now the next step is we're going to look at this triangle here and find that dimension cut across there. That's going to be this one here, cut across here like that at a right angle. So we're looking at that top triangle up here. This is the angle we're looking for. This is R here, but this angle is going to be the same, so we're going to find this angle. We know that this is 16.003. and this is 26.051. So to find this angle up here, we're again looking at a tangent. R is going to be the inverse tangent. The opposite is the 26.051, the adjacent 16.003. So we get R. .44 we're going to call it. So that's our rotation. From that rotation, we need to find the angle of tilt now. The angle of tilt, if we look up here, is going to be found by connecting this point here through the object down to here. That is the angle of tilt. So there's a triangle I need to create there. That's my tilt. What's this dimension of that triangle going to be? This side here is this. No, that's the 10. That would be.
I'm saying the bottom triangle that you just asked about.
Yep. Well, this piece right here is the 10, right?
That's what I'm saying.
And that is this piece here.
Yeah. Right there.
Yep.
Top is 15.63.
Okay, hang on for that. So the question is, how do we find the top? That top is this piece here. Have all of you found that already, or no?
I thought you were asking for it.
Nope. That's what I'm going to have you do right now. If you don't have it, find that length, so that would be the top of this piece. That'll be that length. So find that in your notes quick. I'll give you about a minute. So if I'm looking at that, finding that length, I'm looking at this triangle right here. This here angle is 58.44. And this side down here is 26.051. This would be the adjacent side. And the 26.051 is the hypotenuse. So that's going to be a cosine. That's we just found that up here. This angle here is 58.44. This one is the same. That's what we just found here from the rotation. So that's 58.44 has to equal that adjacent side that we're looking for over the 26.051. So I'll put this over 1, and we'll cross multiply and divide. So this is just going to be cosine of 58.44 times 26.051. Divided by 1, which won't change anything, but 13.635. So yes, this is 13.635. That's what you said, wasn't it?
Yeah.
Okay. So now that we have that, you can find the angle of tilt. I'm going to give you about 30 seconds to find that angle of tilt. So we have opposite and adjacent. So this is going to be which function? Tangent inverse. So t is going to equal the inverse tangent of 10 is the opposite side over 13.635 is the adjacent side. So second tangent 10 divided by 13.635. 36.26 degrees. So that's my tilt. So my rotation was the 58.44. And my tilt was the 36.26 degrees. So there's really only about 4 or 5 steps to this. Really 4. You start out, you pick this depth. and you use it to find the length and width here. Once you know that length and width, you find the angle of rotation, which is the same as this angle here. Those two angles have to be the same. Once you find that angle, you find the length of this side. That's going to be part of your tilt triangle. Then we do an inverse tangent to find the tilt. I've got a new packet I got to give you for this. So I'll pass it out. In this new packet, it's going to be pages 410 through 411, 1 through 14. I'll just do 1 through 13 the odd.